Okay, so we're back here. This is where we had left off. You could also write this as 2 cosine x over sine x times sine x. And now this is 2 cotangent x. And then you have 1 over sine x, which is cosecant x. And they're both acceptable to do. Or you could write it as 2 cosine x times cosecant squared x. So either this one, this one, this one, they're all acceptable. Okay. So as long as it's in terms of like sines and cosines, you should be okay. All right, this next one here is ln of secant over cosine x. And now this is actually ln of, now secant is 1 over cosine x times another 1 over cosine x. This is ln of 1 over cosine squared x. And once it's cosine squared, it's always going to be positive, so you don't need the absolute value for this. However, we don't leave this like this. So it's going to be ln of cosine x to the minus 2, which is negative 2 ln cosine x. All right, here we're going to square both sides, but before doing that, I want to bring the cosine and the sine to the same side. So it's going to be cosine x minus sine x equals negative 1. When I square both sides, I get cosine squared x minus 2 cosine x sine x plus sine squared x equal to positive 1. Now, cosine squared plus sine squared is 1 minus 2 sine x cosine x equal to 1. These go away. Negative 2 sine x cosine x is equal to 0. Divide by negative 2. So sine x cosine x is equal to 0. Sine x is 0. Cosine x is 0. Sine x is 0 at 0 and pi. We're not going to take 2 pi because it's open there. Cosine x is 0 at pi over 2 and 3 pi over 2. When you plug them in, right, you can plug them in to either this or this. And if you plug in 0, let's say, you say, okay, is cosine 0 the same as sine 0 minus 1? Cosine of 0 is 1. Is that the same as 0 minus 1? It's not. So that doesn't work. And neither does 3 pi over 2. The only ones that work are pi and pi over 2. Okay, here, what you do here, right, so you have cosine squared and just sine. Okay, you can't have these two in the same equation because there's nothing you can factor out and so on. However, what you can do is notice that cosine squared x is the Pythagorean identity, and when you solve for cosine squared x, you get 1 minus sine squared x. So what I get here is 2 times 1 minus sine squared x minus sine x minus 1, 2 minus 2 sine squared x minus sine x minus 1 equals 0. 2 minus 1 is plus 1, so negative 2 sine squared x minus sine x plus 1 equal to 0. Now, I don't know about you, but I don't like having this negative out in front here before I factor. So I'm going to divide everything by negative and make this 2 sine squared x plus sine x minus 1. Okay, now we have to factor this. All right, so if you like the shortcut, right, you can multiply 2 here. So we get sine squared x plus sine x minus 2. And so now you have sine x plus 2 sine x minus 1. Added 2. Added 2. So finally we have sine x plus 1, 2 sine x minus 1. So here, sine x equals negative 1. Sine x equals 1/2. Right, so where is sine equal to negative 1? At 3 pi over 2. Right, so sine is the y-axis. It's negative 1 at 3 pi over 2. Where is sine equal to 1/2? At pi over 6 and 5 pi over 6. Now, here it says for all values of x, so x is going to be 3 pi over 2 plus 2 pi n, pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n. Okay. Where is this? Okay, so now where is sine less than or equal to negative 1/2? Okay, let's go on the unit circle. Let's talk about where is sine negative 1/2 to begin with. So sine is the y value. It's equal to negative 1/2 here at 11 pi over 6. Right? This is negative 1/2, or same way, this is negative 1/2. And it's negative 1/2 once again here at 7 pi over 6. Okay, if I want sine of x, or the y value, to be less than negative 1/2, so until here, it's negative 1/2. Now, if I want it to be less than that, so if I want my angle so that the y values are here, it's got to be this side, right? Because if I draw an angle lower than this, here, so it's one of these angles here that has the y value less than negative 1/2. So that means it's from 7 pi over 6 less than or equal to x less than or equal to 11 pi over 6. This should say 6. Okay. Good luck.